This video presents two examples of the chi-square goodness of fit test. We are interested in determining whether the Mars Company's claim for the breakdown of M&M colors is correct. The null hypothesis is that it is accurate, that there is no difference between observed and expected frequencies. The research hypothesis is that there is a difference, or that at least one of the hypothesized proportions is wrong. To do the study, we'll purchase a case of M&Ms from our local supermarket and count the number of M&Ms of each color. We'll say that the first two assumptions have been met. We also know that none of the color categories overlap, and that these colors account for all of the data. So the third assumption is also met. We have to wait until data are collected before checking the last assumption. We'll use a significance level of 0.05. There are 6 color categories, so 5 degrees of freedom. Next, we'll look up the critical value of the test statistic. Based on our significance level in degrees of freedom, the critical value of the test statistic is 11.07. We have created the model of the null hypothesis and have determined the rejection region, so we can now test the hypothesis. Without eating any of the M&Ms, we count a total of 2,600, distributed as shown in the column labeled O for observed frequency. We are not hypothesizing the same proportion for each category, so we have to multiply the sample size by the appropriate hypothesized proportion individually. This gives us an expected frequency of 624 for the blue M&Ms. Repeating this procedure, we complete the expected frequencies column, which sums to n. All of the expected frequencies are large, so the sample size assumption has been met. SPSS loves doing calculations, so we'll let it take over from here. The p-value is less than the significance level, so we reject the null hypothesis. We conclude that there is a significant difference between observed and expected frequencies for at least one M&M color. To determine which color categories are significantly different from hypothesized values, we again turn to SPSS. I asked for a table of observed and expected frequencies along with the differences, or residuals. Blue and yellow are the only colors that appear to be different from the manufacturer's claim, so we'll focus on these two groups first. To determine if these frequencies are significantly different from expected, we do a z-test using the residual in the numerator and the square root of the expected frequency in the denominator. The critical value for the z-test is plus or minus 1.96 for a significance level of 0.05. For the blue M&Ms, we find that the observed frequency is significantly lower than expected. We find just the opposite for the yellow M&Ms. The observed frequency is significantly higher than expected. Repeating this test for the other color categories, we see that there are no other significant differences between observed and expected frequencies. Adding these comparisons to our summary of results, we would say that the percentage of blue M&Ms is significantly lower and the percentage of yellow M&Ms significantly higher than expected. We would also indicate that no other color category was found to be significantly different from expected. Our second example uses the chi-square goodness of fit test to check the representativeness of a sample. Researchers conducted a survey to determine what adults in Western New York knew about posterior composite restorations and what their interest level was in these restorations. Random sampling wasn't possible, so they surveyed individuals waiting at arrival gates at the Buffalo Airport. Arrival gates were targeted on the assumption that those waiting there lived in Western New York. This was a long time ago, when anyone can go anywhere in an airport. Because this was a sample of convenience, the researchers wanted to determine how representative it was of the population of Western New York. Education was one of the variables they chose to examine. To do this, they compared their sample's highest level of education to the most recent census data for Western New York, and these are the results. The null hypothesis is that the sample is representative of the population, or that the observed and expected frequencies do not differ. The research hypothesis is that it is not representative, or that the observed and expected frequencies differ for at least one education category. Checking the assumptions, fair or unbiased sampling is what we are trying to determine. Observations were independent, and the education categories are mutually exclusive and collectively exhaustive. The large expected frequencies assumption was also met. Here are the results from SPSS. If you clicked on the p-value, you would find that there are many, many zeros before a meaningful number appears. This means that there is a significant difference between observed and expected frequencies for at least one education category. Z-tests for each level of education show a significant difference from expected for all three categories. They would write up the goodness of fit results and then interpret the nature of the results from the follow-up Z-tests. The researchers also found a significant difference between their sample and the population in terms of the percentage who visited the dentist on a regular basis. However, they were able to spin their findings to suggest that because their sample had a higher education level and greater frequency of dental visits, it was representative of those who might be more likely to pursue information about posterior composite resins. The chi-square goodness of fit test is used to compare two or more population proportions. The null hypothesis is that the observed proportions are equal to expected proportions, and the research hypothesis is that at least one observed proportion differs from expected. If the null hypothesis is rejected, observed and expected frequencies are compared for each category to determine significant differences.